Hello class, this is the content from chapter 8 that you want to be familiar with. This is types of joints, and essentially we can classify joints functionally as well as structurally. If we classify a joint functionally, we are indicating the degree of movement that can take place at that joint. So for example, we have joints that are freely movable, like our knee, and then we have other joints that are immovable, like the sutures in the skull. So we classify them based on their degree of movement. The immovable joints are considered synarthroses. So if you look underneath the functional classification, you see number 1, synarthroses. Those joints are the immovable joints. And the example that I just gave you was the suture. That's the example you should remember. Those are places in the skull where skull bones come together. The joint itself does not have a joint cavity, and the tissue there is fibrous connective tissue that holds those bones together. We can also classify joints structurally, and that indicates the kind of material that that joint is made of. So for example, I just mentioned that the synarthrotic joint, being the suture, is made of fibrous connective tissue. Well, that's its structural classification. We would call a synarthrotic joint a fibrous joint if we're referring to its structural classification. Fibrous joints will have fibrous connective tissue with no joint cavity. So if you look down at number 2 now, you see the term amphiarthroses, and that's a slightly movable joint. That would be that particular joint's functional classification. It's slightly movable. Its structural classification would be cartilaginous, because the joint itself consists of cartilage and there is no joint cavity. So the examples that you see here, the epiphyseal plate is actually considered a cartilaginous joint, because that is where two bones come together. If you consider the epiphysis coming together with the diaphysis at that epiphyseal plate, that plate itself is not made of bone. That plate is made of hyaline cartilage. So technically, it's considered a cartilaginous joint. The cartilages that connect the ribs to the sternum, those are cartilaginous joints, and again, that would be defining its structural classification. But if you were to determine the functional classification for that joint connecting the ribs to the sternum, you would call it an amphiarthrosis, because it's slightly movable. So you know that the rib cage can move, can expand as we breathe, so that's slightly movable. The other two examples that fall under the cartilaginous or amphiarthrotic joints are the intervertebral joints. So those are the fibrocartilage pads that we find between the adjacent vertebrae in our vertebral column. The last one you see there is the pubic symphysis. The pubic symphysis is structurally very much like those intervertebral joints. It's a pad of fibrocartilage, but it's found in the pelvic girdle on the anterior side, where those two pubis bones would join in the front. Our last type of joint is the diarthroses. That joint is freely movable. If you are determining its structural classification, you would call it a synovial joint. These are all the joints of the limbs. So they're the joints that you really kind of think of when you're thinking, what is a joint? So starting with the arms, for example, the shoulder, the elbow, the wrist, the joints in the hand, the fingers, those are all diarthrotic joints, as is the hip joint and the knee and the ankle and those joints down in the feet and the toes. Those are also diarthrotic. We call them synovial if we're referring to the structural classification, and a synovial joint does have 5 distinct features. Those 5 distinct features are listed below, and then there's a picture on the following page of a synovial joint. You do want to be familiar with that picture for exam purposes and be able to identify those 5 distinct features. So to begin with, I'm going to go ahead and begin discussing that picture. So if you'll turn, go to the next page where you have the picture of the synovial joint. We can begin with, for example, let's go ahead and start with the joint cavity. Synovial joints are the only joints that have a joint cavity. So there is an actual open space between those two bones. It is enclosed, but the open space itself contains synovial fluid. That is because that joint is lined with the synovial membrane. So the joint cavity is one of its characteristics. The synovial membrane is another characteristic of this joint. That synovial membrane is made of loose connective tissue, and it produces synovial fluid that will occupy that joint cavity, will occupy that space. There are macrophages in that synovial fluid that are responsible for phagocytizing any cellular debris or any sort of solid material that might end up in that joint cavity. Outside of that synovial membrane, you see a fibrous capsule. That fibrous capsule is enclosing the joint. It is made of dense connective tissue or regular connective tissue, and it is on the outside of the synovial membrane. It is continuous with the periosteum. And remember, the periosteum is the outer connective tissue covering around the outside of long bones. So that periosteum is continuous with that fibrous capsule, which encloses that joint. Also considered a characteristic or feature of this joint is the articular cartilage. The articular cartilage is the cartilage that we find on the ends of long bones. So they cap the ends of long bones. And that was a concept we learned when we did the structure of a long bone. The articular cartilage is made of hyaline cartilage. You should also be familiar with a type of arthritis. There are actually 3 types of arthritis. There is rheumatoid arthritis, there's gouty arthritis, and then there's osteoarthritis. And osteoarthritis, which is commonly referred to as OA, is a wearing away of that articular cartilage. So those are the components of a synovial joint: the articular cartilage, joint cavity, fibrous capsule, synovial membrane, and synovial fluid. Please read about those characteristics on the previous page. Also, you should be familiar with what a bursa and a tendon sheath is, and those are also described in this handout. They are essentially made of a synovial membrane filled with synovial fluid. A bursa is a little sac tucked between adjacent structures within a joint, and they act as ball bearings to reduce friction. And a tendon sheath is like an elongated bursa which wraps around or jelly rolls around a tendon. Also, again, the function is to reduce friction at that joint. And here you've been provided with a few pictures. Okay, well, thank you very much. Let me know if you have any questions.